Yeah, well, that like.
All right. Let's go ahead and finish this review. So we're ready for number 2, and the question says, determine if the function can be linear, quadratic, or neither. So one thing that we really need to pay attention to are these input intervals over here. This is x. X is the input in a function, right? Are these same width intervals? No. You can't make a conclusion about anything except linear if the input intervals aren't the same width. And the only reason you can do a linear one is because why? That rate of change is always constant, right? No matter what part of the line you look at, the slope will be the same. So that's all we can do here, is check to see if it's linear. So I'm just going to check the first couple. What would my rate of change be between these 2 points? 2 over 1? Right? What would my rate of change be between these 2 points? 2 over 2. Is this linear? No. And you can't make any other conclusions, guys, because the intervals aren't the same width. Okay? So we're done with that problem. It's not linear, and I have no idea about the other. The input intervals are not the same width. All right. What about 3? Well, shoot, is 3 kind of the same thing? All right, so it could be linear. So let's check. And if it's not linear, that should be just like this one. Okay, so this rate of change right here would be 4 over 2. How about here? Ooh, this looks promising. Let's keep going. All right, so this would be 10 over 5. Okay. And this would be 2 over 1. So what's my conclusion? Linear.
So for the last one, the slope, like if you calculate it out, the slope changes by, it gets divided by 2 at every interval. Would that show that it's quadratic or no?
Oh no, it's not quadratic. This is something that we're going to learn later, because the input values, look at the input values.
They're double.
They're geometric, but they're being times by 2. So this is going to be something, some other kind of special function. It's not quadratic. Okay? All right, number 4. I'm going to save that surprise for later. We gotta get this stuff mastered first. Okay, so let's take a look at this one. What do you think here? First of all, are my input intervals okay?
Yeah.
Yep, we're going up by
4.
4, width is 4. So all of these changes are 4, okay. So what's happening on the other side? All right, so this difference here is 1, this is 7, this is 19, and that is, good Lord, 37? Check my math, is that right?
Yep.
Yeah.
Okay, so my average rate to change would be 1/4, 7/4, 19/4, and 37/4. Just to be double sure, I'm gonna look at my second differences. Are they the same? However, there is something about those second differences, right?
They change by the same amount, so it's.
So the third differences would be the same? And if the third differences are the same, it's not linear, it's not quadratic, but it's cubic. Yeah, which wasn't an option. So the answer technically to the question is neither. But because of the observation we made, it is cubic.
I was just wondering, how do you tell again if it's like concavity?
We haven't gotten to that part yet. the bottom ones are concave, I will talk about that. Okay, number 5. What's happening in number 5? All lines are straight, Alex, you mean a horizontal line?
Yeah.
Yep, it's a horizontal line. All of the y values are the same, so all of the rates of change will be 0. And if the rates of change are the same, it's linear. Good, good, good. And what about 6? These are not the same, are they? Okay. These are not the same size intervals. Would you agree with me? So the average rates of change are not the same either. This is going to be 1, 1/3, 1/5, and 1/7. This is the average rate of change. Right? Now, because the second differences would all be the same, 0, this could be quadratic, but I can't make that conclusion because these aren't the same. The fact that these are all going down would tell me what? If the average rates of change are decreasing, it would be concave down. So it's possible this could be quadratic, but I can't make a definitive conclusion based on this because these aren't the same size.
So does it matter if, like, the changes in the rates of change of the x's, like the second row is all 2?
No.
This was the same as
So what that would mean is, let's see, if we looked at the rate of change over here, the rate of change over here, and the rate of change over here, I don't know, I'm getting all confused. No. What?
So would it be quadratic?
It could be. You can't say it is. Like, one of these over here, like this one, we said, oh no. We said this one was cubic. We can make that conclusion because these are all the same. You can't make a conclusion about these things unless, except for linear, you can't make a conclusion unless the input intervals are the same size. Okay, we gotta have that.
So should we put quadratic if the question says it could be?
Could be, yeah, I would say could be. All right, now number 7.
Wait, on like a test, will we just write could be quadratic?
You would say could be quadratic.
Alright.
Based on the second differences, it could be quadratic. I mean, think about it. You're being asked to make a conclusion about a curve based on 5 data points. So unless the 5 you have are special, and that means same size input intervals, you can't really definitively say.
And you should, like, don't go to the second term on their x values.
That's how, no, not on x values, no.
So like on the numbers, would that not be the same thing? That it could be quadratic, it's all the second one.
Wait, yeah, no, I'm with that.
So what would they be, 2?
They're all 2, so the second
Yeah,
one.
that could be the same thing. Now, I said neither one because I know what that is, because those x's are in a thing, but that could be based on second differences, it could be.
Okay.
All right, let's take a look at this. Now, all we're doing is figuring out if it could be concave up, concave down, or neither. Okay, this is really good over here, okay. Let's find our average rates of change. So this would be, this is 4/2, right? So that would be the average rate of change for those 2 points. These two would be 3/2. I'm doing the average rate of change. This would be 2/2. And this would be 1/2. What's happening to those average rates of change? They are decreasing. And if they're decreasing, then our curve could be concave down. Concave down. Decreasing rates of change mean concave down.
Do you write could be concave down, or
Yep.
do we write concave down?
Yep. In the directions, he says could be. So I'm figuring out what this could be. All right, how about number 8? Okay, so this would be 3/1, a negative 3/1. This would be negative 3/1. Okay, they're all gonna be negative 3/1. If your rate of change is constant, then you are a line. Okay, that's not a could be, that is a line. And then the last one. So 1, 4, 7. Okay, got nice X's. All right, so here my rate of change would be 2/3. Here it would be 4/3. Here it would be 8/3, and here it would be 6/3. Shoot, these are looking good until here. These are going up, right? But that one went down, so we can't draw any conclusions because we got increasing and decreasing rates of change. So no conclusion about concept. Okay. Now, I'm gonna do the 2 things. One is another review sheet. And the other is your next set of notes, so you can have them in your hands. Alright, so you're looking at that review sheet, guys. And remember what we talked about yesterday, problems are different. Right, so now you got a different problem. Mr. Glasswater is an amazing guy. He revised some of his stuff because there was a question like this, that kind of picture, actually on the AP exam this year. So let's see what's going on here. The first problem. F, no scale is indicated, no axes are presented. The t coordinate of G is T sub 1, and J is T sub 2. Okay, and this is negative 4, 7, and this is negative 5. Okay, so the question is, on the interval from here to here, G to J, what can you say about that curve? What can you say about the curve on that interval from here to here? Okay, well, look at your choices. H is positive and increasing, positive and decreasing, negative and increasing, negative and decreasing. So if you're going from G to J, would you definitely say that the curve is decreasing? Now, is it positive and decreasing or negative and decreasing? Positive. Guys, where would this point be plotted? G, where would negative 5, 9 be plotted? Up here?
Yep.
Where is negative 4, 7 plotted? Right here? Curves are positive if they are above the x-axis. We're not talking about a rate of change. We're not talking about anything except where is it? H of x is y. So when we want to know where H is positive, we want to know where is y positive, right? Or are your y's positive or negative? And these y's are positive. So this curve is positive and decreasing. Okay? Question 2, just double I here. Describe how the rate of change is changing on that interval. Now, some of you said it's concave up, and you are right. If it's concave up, then how is its rate of change changing? Increasing. Increasing rate of change because it is concave up. All right, number 2 is exactly the same situation. So let's look at that one and see if we have good luck with this one. The 2 points you're looking at here are K and P. Okay, so look at K and P. What can you tell me about the function H? H is negative and increasing. And we know it's negative because we're looking at its y coordinates. That's what H is. H is y. All right. So how's the rate of change changing? It is decreasing from K to P because we are concave down. Everybody got that? Next page. Good grief, there's another one. All right, go ahead. You 3 and 4, they're the same sort of thing. See if you can figure this out. Number 3, you're going from F to G. Tell me about the function. What's happening to H? Positive and decreasing from F to G. We're going down. And how is the rate of change changing? Decreasing because we are concave down. All right, one more for good measure. We're looking at J and K. What can you tell me about the function? Negative and increasing, going from J to K. And since it is concave up, its rate of change is increasing. Right, now we got a new picture, okay. Some points to label. On which of the following intervals is F negative and increasing? Negative and increasing. What? Our options are A to B, B to C, C to D, and E to F. B to C. B to C. What's happening as you go from B to C? You are increasing, but your function is negative because it's under the x-axis. Which of the following statements about the rate of change of F is true? The rate of change of F is negative on the interval from B to C. I'm just reading each one, trying to figure out. So from B to C, would you say the rate of change of F is negative? No, very good. Rate of change is slope, right? And from B to C, isn't my slope positive? Good job. So that's a no. All right. The rate of change is negative from C to D. No. The rate of change is negative from D to E. There it is. There's your correct answer. Rate of change is slope. And this is simply asking about the slope. All right, which one was that? That was 6. 7? Tell me what you think about 7. Now, we're talking about the rate of change increasing and decreasing, right? What does that have to do with? Concavity. This is a concavity question. We're not talking about positive and negative, we're talking about increasing and decreasing. So, which one of those is true? D? The rate of change is increasing from E to F? Heck yeah, because what's happening from E to F? We are concave up. And if we're concave up, our rate of change is increasing. If it says rate of change is increasing or decreasing, that's concavity. On which of the following intervals is F decreasing? So we're talking about the function decreasing. Stop right there. If the function is decreasing, what does that mean? It's going down. That's all it means. Decreasing means going down. So where is it going down and concave up? I would say right, yeah, A to B. Isn't that decreasing and concave up? Where are we increasing? -5 to -1. That whole piece. Now, it's got different slopes on a couple of sections there, but the whole thing's going up, right? From -5 to -1. Where is it positive and decreasing? Positive and decreasing would be from -1 to 2. -1 to 2. Remember, if we want it to be positive, it's got to be above the x-axis.
You use brackets, right?
Yeah, you can use brackets. And no one's going to argue if you use open intervals, though, because when you're talking about increasing and decreasing those endpoints, yeah, it's up for grabs, but yeah, fine. All right, number 11. On what? Point A, okay, only point where the graph changes concavity. So what would point A be called?
The point
A point of inflection. And what happens at the point of inflection? The rate of change is changing the fastest, right? Maximum rate of change. On what intervals is the rate of change negative? From -5 to -4, and from 0 to 4. Because if the rate of change is negative, you have to slow your brains down, guys. If the rate of change is negative, that means the slope is negative. That means the curve is going down. Where is it going down? On what intervals is the rate of change positive and decreasing? Okay, so positive means it's going up, but decreasing rate of change means we are concave down. So where are we going up and we're concave down? -2 to 0, basically, yeah. Is that okay with everybody? All right. For each scenario below, positive rate of change or negative rate of change. In other words, if you found a slope, would it be positive or negative? The amount of money in a vending machine versus the number of items remaining inside the vending machine. Negative. The more money that's in there means more stuff's been bought, so there's fewer items in there, right? Everybody good? Negative? Number 2, days since flu season began and the number of people who have caught the flu. Positive. The longer we go, at least in the beginning of the epidemic, the longer we go, the more people get sick, right? Number of years since 2000 versus the number of Teslas on the road. Positive. The number of miles driven since filling up versus the amount of gas left inside the tank. Negative. The more miles you've gone, the less gas you have. So we're good on that. All right, the function g is given by this equation. Use your graphing calculator to find the values of g for the x values indicated in the table above. So they give me the x values and they give me the function. Can we find the y values? Let's go ahead and get that table filled in.
I found it. Is it second trace value?
Yeah, maybe, let's see.
That's what I did.
Because then you can just keep re-putting in the
If you
thing.
put your equation in,
Yeah, like with the
Yeah, and then I'm
x's.
just-
second trace value.
Yeah, it's just like second.
Yeah, that's it, yep, I couldn't remember. Yeah, so if you go ahead and put your equation into y equals,
You can do that, but it takes way longer if you like plug them all in individually.
yeah, you can plug it in, sure. But if you go to, you just type in your equation, and then bracket, and then do second, and then do second calc, and the first option is value. Then the calculator will ask you for an x value, so if you put in 0.5, you get 0.45. And then do it again, so second trace value, and now you can put in, well, second trace is the calculator, you want the calculator.
Sweet. I don't, where's the calculator?
Just second.
Look
just
above
press
your
second
trace
value.
button.
Oh, it's second trace value?
Yeah.
Yeah. Now, could you also fill the table in by just plugging in those values? Absolutely. It'll take a little longer, not a ton of time, but you could do that and get your values, okay? Now, we got all the values filled in there. You're gonna find the average rate of change. Be sure to show your setup. We keep emphasizing this. So, for example, let's see, let's divide and conquer here. Greg, can you guys over there, do you know how to find the average rate of change for that first interval? So G of 1.5 minus G of 0.5 over 1.5 minus 0.5, right? You guys find that one. Gus, you guys, would you find the next one? So G of 1.2 minus G of 0.8 over 1.2 minus 0.8. And you guys over here, find G of 1.1 minus G of 0.9 over 1.1 minus. And I'll do that last one, or this price, and then we'll do that last one. Why do we have a number? So ours is. What'd you guys get over there, Fred, in your row?
We got 0.9.
0.9?
Yeah.
All right, what did we get here? 0.48. Perfect, what did we get here? 0.42. All right, what's the question? The question is, based on the average rate of change, what do you think is the rate of change when x equals 1? Give a reason for your answer. What do you think, Sophia?
It's 0.4 because the 0.99 and 1.01 is the closest to 1 because it's only one time.
Yeah, it looks like, this one's like way off, but that interval was huge, right? That was a big interval. As the intervals got smaller and started narrowing in on 1, so this was 0.2 on either side of 1, this was 0.1 .1 on either side of 1, and this is 0.01 on either side of 1, it looks like they're getting closer to 0.4. Yeah, that would be approximation. Yep, just what Sophia said, we're doing a smaller and smaller interval. When we did this in our notes, this is how we approximated, if you remember, the instantaneous rate of change. We need to average two things together, but the smaller we make that interval, the closer we get to that middle number, right? So we're approximating the instantaneous rate of change. Okay, number 6. Sketch a line tangent at each of the points. Okay, you can do that. And then list the rates of change from least to greatest. So he's having you draw those lines so that you can literally see the slope. The slope is the rate of change. So when you draw in those tangent lines, we want to know least to greatest. Well, you can tell me right now which one is the greatest, because it's the only one that's positive. So the last one, the greatest one is B. What's the one right before that? C, because that one is 0. Now these two are both negative. Which one is most negative? Looks like D is most negative, so it would have the smallest slope, and that leaves A to be next. Did anybody not follow that? So if he didn't tell you to draw on the lines, would you know to do that? You're comparing rates of change, so you're comparing slope. For each of the following statements, circle the correct answer. Okay. From point A to point B, the rate of change is what? A to B. The rate of change is decreasing, increasing, decreasing, increasing. Which one? Increasing, how do you know? Concave up. Now, it's important that you slow your brain down and read the question. The rate of change, okay, not the function itself, because the function itself is decreasing, but the rate of change is increasing because we're concave up. Okay, what about B? B to C. B to C. The graph of H is increasing, the graph going up, because the rate of change is positive slope going up. C to D, the rate of change from C to D, the rate of change is decreasing, because the curve is concave down. Okay? Those are such basic, easy concepts, but it gets all confusing. You have to make sure you're reading exactly what we're talking about. Are we talking about the curve? Are we talking about the slope? Are we talking about the change? What are we talking about? All right, so then we've got these last ones, which are like what we just did. So take a minute. We have a few minutes, and let's see what you can come up with. The first part, 1 to 6, you're determining if it could be. If it could be linear or quadratic. All right, so go ahead, take a second, get through as many of those as you can. Then we'll skip down and do a couple at the bottom. got an answer, share it. Or, and, like, number one.
Number one, cubic?
Number one's what?
Cubic?
It's not even.
I don't think it's even cubic. We have same size intervals, right? So we can look at the differences. We have 1, 2, 4, 8. So the second differences would be 1, 2, 4. Yeah, 1 is neither one. Remember, you can use your first, second, third differences because your input values are the same size. So we're good on that one, but it doesn't work out.
The next two plug
One's neither, I don't know.
I got to plug that.
The next one looks quadratic. And you can explain that 2 different ways. How did you explain it?
Because of 4.
We can either say the second differences are the same, or we can say the average rate of change is going up by the same amount, right? So it's linear, the average rate of change is linear. All right, so finish that up. I will work those last ones out and, I don't know, do something with them, send them to you somehow.